Morning, everybody. Wolfie here. Another episode of Talking Head. No politics today. I want to talk about something geeky and nerdy. Because I've wanted to do this for years. Even at my last job, it was kind of a running gag that I wanted to try to. I wasn't even IT in my last job, and I'm not IT in my current job. So, sort of a pie in the sky wish. But it was a running gag that I wanted to try to get just a small research budget put together to try to build one of these things on the cheap. And it just never panned out. And I think now I have the opportunity in the next few months to start trying to piece together one of these things. And so I wanted to talk about it. And I don't know, see if there's any opinions out there. Maybe this idea is just pie in the sky ridiculous and it won't work, or maybe it'll be really cool and work out just fine. So here's what I want to do. I want to build a Ceph cluster for my home. Ceph is a distributed networked file system. It does all sorts of really cool things and lots of buzzwords that I don't think we need to get into, because none of the detail really matters that much. I'll get into a little bit, but the real nitty-gritty doesn't matter all that much. The basic points, well, the main point of it is, I'm going to be building a new NAS, network attached storage, and I'm going to buy a piece of hardware that takes a bunch of disks. You stick disks in it, and it combines them all together into one giant, one great big storage volume that you can stuff lots of data into. And the device is expensive. It's going to be like $1,500. So trust me, I got to save up for that. And then the disks I'm putting in are going to be about just shy of 200 each. And it takes 12 disks to max it out. And I plan to do that right from the start. They're 10 terabyte disks total. So, and I'm going to set up some redundancy so that, and this is the benefit of a NAS. You put it takes some of the storage capacity you give it and uses it for redundancy so that you can, disks can fail because hard drives break down and die over time. It's inevitable. But you can lose, in this case, the way I'm going to set it up, you can lose 2 disks and still not lose your data. And that's pretty cool. And just by itself, yeah, it's going to be like $4,000 to set this thing up, but it's going to be 100 terabytes of storage that we can use in the house and have 2 disk redundancy. So I can, basically, when a disk fails, oh shit, it's time to order a new one. Although, I'm probably going to order 13 disks instead of 12 so that I have a spare ready to go. In case you're wondering where I'm getting 10 terabyte disks for $188, I will be buying external Western Digital 10 terabyte disks. There's some, the external backup storage things, they're branded. They're not meant for NAS use, which doesn't matter because their NAS drives are no different. They just have some different firmware settings on them. But it doesn't matter. The newer NAS devices can fix or adapt to the firmware that regular disks have. So that's not really a problem anymore. But yeah, you take those external drives and you just shuck them. You rip open the case and you can take the disk outside or out of the case,
right
and then you've got a bare desktop drive, and you just stick that in the NAS. Really awesome. And yeah, not enough people do that. A company called Rackspace, not Rackspace, Backblaze, sorry. Rackspace is a hosting provider. Backblaze, they're a backup company.
Ramp, then merge onto Florida
They do the
408
shucking thing where they'll just buy the cheapest disks they can get their hands on, and they're always externals, and they rip them out of the enclosure and stick them in their own custom hardware Their servers are built to take like 45 disks, which is just crazy. And they take the same approach. The disks are cheap enough that if one of them fails, whatever, they've got plenty more, and they've got redundancy on their system. Now, they do redundancy a little differently, and that's where stuff like Ceph comes in. And the reason I'm thinking of doing all this, you gonna let me merge, or am I just gonna, okay, I'm just gonna shove my way in. Good job, asshole. Anyway, yeah. So the reason all this has come up is that my current storage system is usable, but it's not perfect. And in fact, it's actually pretty brittle. I have just disks in USB enclosures that hold like 4 or 5 disks in one box, and they're attached via USB 3 to my beefy server named Burley. And it works okay, but there are some limitations. For one thing, USB is not the fastest thing in the world, even 3.0, and so I'm not getting the best performance I can out of these disks. Now, we're talking about a home network, so it's just gigabit Ethernet, and really maxing out disk performance isn't a huge deal, because you're talking about combining the efforts of 4 or 5 disks at a time. If you've got data spread across all of them and you're trying to read it, you're getting the combined throughput of all of those disks. So it's easy enough to saturate the gigabit link with these disks with the way it's all set up. The weak point is that because of how they're connected, groups of 4 on one physical connection, it doesn't make any sense to create a logical volume with all of those disks. So, because if you lose a connection, you have 4 disks go away all at once, and that means your logical volume, if it doesn't have 4 disk redundancy, will panic and go, oh God, I don't have enough pieces, I'm panicked, how's that? And ZFS, which is a really good file system, is still not perfect in how it deals with disk failures. So it's just a mess to get that working. So what I'm limited to doing is creating a volume pool, or a pool of disks rather, just with those boxes. So if I have a box with 4 disks in it, I make a volume out of those 4 disks, a pool out of those 4 disks. And I get 1 disk redundancy, and ultimately get the capacity of 3 of the disks. So like, I've got one box that's got 4 8-terabyte disks in it. And that adds up to 24 terabytes of usable space, because one of the disks, because there's single disk redundancy. One disk can fail, and I still don't lose my data. And then one of the other boxes has 4 terabyte disks in it. A third box has, I think, 6 terabyte disks in it. 4 more of those. And then I've got a fourth kit that's not even a fully enclosed box. It's just a tray that you slide disks into. It holds 5, and there's 5 terabyte disks in that. So that adds up to, with single disk redundancy, that gives you 20 terabytes. I have a lot of storage space, but it's split across 4 different volumes, because I've got 4 different boxes of disks attached to this server. And the trouble with it is it's all spread out. You've got a server plus 4 different boxes of disks, all spread out across my bedroom floor, which is where all this is set up. And it's vulnerable to things like cats and also cats. Yes, the little furry bastards have actually managed to unplug the disk arrays before in the past, and so that's actually one of my concerns that maybe this new NAS will resolve, because it's going to go on a desk where the cats don't go. But once I've built the new NAS and transferred all the data to it off of the existing pools of 4 and 5 disks each, I'm going to have a bunch of disks left over. A bunch. And I don't know what to do with them. And it feels bad to throw them away. So I've decided I'm going to try to build a Ceph cluster with them. So the idea behind Ceph is that they take a commodity hardware, meaning just some, random generic servers you can ostensibly build for $300 or $400 a piece. This is their view. This is their vision, not mine. Just saying. It's going to be cheaper than this. But you take whatever servers you have with whatever disks are in them. You set up Ceph on these hosts, and you give it access to these disks. You link them together, and you get one giant pool for data storage. No matter how many hosts and how many disks you have, it all collectively works together over the network to expose a single giant ball of storage, just a great big box. And it takes care of all of the grunt work of spreading data across different nodes and different disks for redundancy purposes. And in theory, all you do is use it. It does all the heavy lifting. And the cool part about it is that it is self-healing and self-balancing. So let's say you've got a Ceph cluster with, 20 nodes in it. You've got 20 servers all interconnected over a network, and they're all talking to each other, and they each have one disk in them. Well, and they're all working together in this cluster. And let's say you're using, erasure coding, which is sort of like RAID parity. It's a little different, but it basically means instead of having to keep, say, 3 copies of every piece of data, you can just keep, like the way they put it, 10 stripes, where you only need 8 of them to reconstruct a chunk of data. So you can lose 2 copies, 2 chunks of a piece of data, and still be able to reconstruct it. It's just redundancy. That's all you need to know. So let's say you've got that enabled, and you got 20 nodes, each with one disk. If one of the nodes dies, just drops off the network, goes away, the network notices that. Like the Ceph cluster notices, hey, this host is gone. Oh shit, I just lost a bunch of shards. I better start healing. It'll get the rest of the nodes working together to reconstruct the missing shards of data. And it'll rebalance all across the network so that it gets back to the same level of redundancy that it had before the disk failure. And this happens automatically. It's really cool. And so then you go and fix the node, like maybe the hardware just turned off, or a cat tripped over a power cord, or the disk actually failed. So you go and you plug it back in, turn it back on, or you replace the disk and set the node back up again. Well, the node rejoins the Ceph network, or the Ceph cluster, and again, Ceph goes, hey, wait a minute, I've got more space now. Neat! And it may decide, according to its own rules, according to its setup, that, well, I should probably rebalance everything back to this new disk so that everything is spread out properly. And it'll do that automatically too. And this all happens in the background, and you don't have to do anything apart from set up the node again or bring it back up and rejoin the cluster. That's all you have to do to keep this thing rolling. And it's really cool. So I want to try my hand at setting one of these up. Now you'll notice the when I mentioned you need servers for this, and I said these things, hey, jerk, cost between $300 and $400 because they're PCs, they're servers. You're like, how are you going to do this cheap if you're using $400 nodes and you're talking 20 of them? Well, I'm not. It's not going to work like that. The reason I'm calling this an experiment is because I'm going to be trying to use what Ceph would consider underpowered hardware for this. But I think these could actually be fucking perfect. Pardon the language. Especially just for home lab use. This is not going to be something that's serving a supercomputer data as fast as possible. It's not going to have 10 gigabit Ethernet interconnect. It's not going to be running on some big ass beefy switch on an InfiniBand network, and it's just going to be running over 1 gigabit Ethernet. It'll have its own network for the nodes to talk back and forth to each other, and there'll be a router in between the home network and this Ceph cluster network. But yeah, as far as the servers go, I'm going to use these, and they seem tailor-made for this. There's one limitation that I think may have an impact that makes this thing super slow or will actually break. And so that's why we experiment and test things. These little gadgets, if you ever heard of a Raspberry Pi, I'm not using those, but if you've ever heard of those, they're little credit card sized computers on a board. It's literally a credit card sized thing that you give power and you plug, like you put in a SD card into, and you can boot Linux on it. You get it's a computer in the size of a credit card. Little tiny thing, low power. It uses like 2 watts, or maybe 10 watts of electricity, if that. So they, really low energy consumption, and they're decently spec'd. Raspberry Pis actually aren't. They're kind of low power, like really low power. But another company out there called Hard Kernel, silly name, they have a line of single board computers called Odroid, and they've made a variety of them over the years. And the one that I'm going to use for this Ceph cluster, I forget the name of it. It's like it's not HC. It's the Odroid. I'll have to mention it in the description. I forget which model it is, but it has. It's smaller than the size of a credit card. It's a tiny, tiny board, but it has a built-in SATA port, so you can physically connect a single disk to it, and it comes in its own aluminum case that's big enough to hold a 3.5 inch disk. So you can put a desktop drive in this thing, and it comes with a case, and they're stackable. So you can pile like 4 or 5 or 6 of them just in a neat little stack on your desk. They have a network. They have an Ethernet port. They can run off of micro SD card, or they have their own little custom eMMC flash that you can stick on them for storage for the OS. They have 8 core CPUs, and the way they've arranged it, it's like 4 really fast cores and 4 kind of slower cores, but it's still 8 CPUs. And they all work in Linux. It sees all 8 of them at once. 2 gigs of RAM, which is the limiting factor. They're 32-bit chips, ARM instead of x86. So these things don't run Windows. They run Linux. And I think you can get FreeBSD to run on them too if you're really playful. I haven't seen much indication that people do that. But anyway, Linux is fine because Ceph runs on Linux. And there happens to be a port. ARM happens to be one of the supported platforms for Ceph. So the different pieces of a Ceph cluster, I think there's 2 minimum required things for a cluster, and then a third type of thing when you want a file system on top of the cluster. By itself, the cluster just provides an object store, meaning I have this blob of data. Hey, Ceph, I want to store it. It goes, okay, here's this long number that identifies it. Give me your data. And you just blast your data at it, and it stashes it in the object store. And if you want it back, you ask for it by that long-ass number, which is fine. But of course, that's not how a file system works. You expect the file system to support folders and file names and that sort of thing. So there is a layer that sits on top of Ceph. It's part of the Ceph project, and it exposes a POSIX-compliant file system. And that's what we want. So the basics of a Ceph cluster are, there's two of them. There's a monitor node that keeps track of the whole cluster, monitors its health, and manages balancing and replication. And then there are OSDs, object storage devices, or daemons. Those are the storage nodes. You have one OSD per disk. So if you have a host that's got multiple disks, you run a single OSD on that host for each disk. But that's not going to be the case in my setup, because each of these little single board PCs are going to have one disk attached each. So, that's no big deal. Now, for a file system on top of Ceph, you also need a third thing, and that's called the metadata server. And that is a component that keeps track. It's a tricycle. Neat. Sorry. The metadata server keeps track of all the.
Take exit 5 for Florida 435.
Shut up, Betty.
Kirkman Road.
Sorry, the metadata server keeps track of all the little nitty-gritty details of a file system. Stuff like, where are these files located, and what directories are there, and just stuff like that. Okay, I have found the slow lane. There we go. It's sad when you get behind a truck and you end up going faster. So anyway, minimum requirements. I am told that Ceph monitor daemons, or monitor nodes, don't have to be all that powerful. But for a fully redundant network, you need more than one, or cluster. You need more than one of these. Because if one fails, if you only have one, well, if you have a Ceph cluster and no monitors, you don't have a Ceph cluster. It goes offline. If you have multiple monitors, you can lose one or two, and as long as you've got one monitor left, you're okay. You've still got a cluster. And it's the same with the metadata servers for a file system. If you've got, or so long as you have one metadata server that's running, you're okay. If you lose one, but you've got like 3 total, you're still okay. So the name of this game is redundancy.
In half a mile,
They recommend 3 monitors.
Kirkman Road.
And if you're doing file system stuff, they recommend 3 metadata servers too. Now they can be on the same box. Apparently they're not all that heavy in resource usage. So monitors and metadata servers can apparently live on the same box. So I'm going to try that at first and see how it goes. Now they make...
In 1,000 feet, use the left 2 lanes to turn left onto Florida 435 South, North Kirkman Road. Use the left 2 lanes to turn left onto Florida 435 South, North Kirkman Road.
So I'm going to try just using 3 nodes as metadata and monitor, and I think that'll be fine. And then the rest, I'm just going to build up storage nodes. And I can use the disks that I have left over from my current, makeshift NAS setup. Once I get the new one all set up with new disks, I can use these existing disks and maybe 6 to 8 of these little breadboard computers, and they're $50 each. So it's only going to cost me a few $100 to put all this together and test it out. And if it ends up not working, well, okay, I'm out a bit of money, but I'll still have 8 neat little computers with a disk attached that I can do other stuff with. But I'm just interested to see how well it works. What I want to be able to do is, set up like 8 disks into a storage system, stash like 8 terabytes of data on it just to see how it handles it, and then unplug a disk and see what it does. And see if I can still get my data out of it after, it's finished rebalancing everything. Or even during the failure. That'll be cool too. So yeah, that's what I want to see. And if it works, and if it's stable, then I can just add more nodes and start using more of my disks and build up another nice, coherent NAS for extra shit. Now, what are we going to do with 100 terabytes of storage on the new cluster, on the new node or new NAS? I've got no idea. And then if I actually get this thing set up with Ceph correctly and it actually works out, I'm going to have like a bunch of 4 terabyte disks, a bunch of 8s, a bunch of 5s, and a bunch of 6s mashed together. It's going to be something like 50 or 60 terabytes of space extra. And I don't know what the hell I'll do with that either. I guess maybe I'll download all the porn in the world. But something like that. But at any rate, that's going to be an experiment that I will be doing over the next few months. And I just wanted to babble about it to see if there's any opinions on it. If you've got any experience with Ceph, let me know. I did talk to the Ceph mailing list a few months ago and asked some questions about it. And they seemed to believe that the whole thing will work, but the limitation will be memory on the storage nodes. I guess 2 gigabytes of RAM is really, really low, like very small for an OSD. And apparently it works just fine without a problem during normal operations, but I guess during a rebalance or when there's recovery going on, it takes a lot of memory, and I guess it can either really slow things down or it can. Well, they weren't really clear on what happens when it gets low on memory. Either it'll slow down really bad or it'll fail, like it'll stop repairing or replicating or whatever. And I don't want that. They did give me some advice on a setting I can tweak that'll make it less likely to have a memory problem. So I'm going to do that, and we'll build this thing up and see how it does. I'm kind of excited to get this built. And if it works, I'll write it all up and document it for people, so for posterity, so other people can try it. But if I can get this to work, it's going to be a fairly low-cost way of combining an arbitrary number of disks together into redundant storage. The reason it's more flexible than RAID is that you're limited to, it depends on the RAID level, but you're stuck with between 5 and 12 disks before RAID just becomes unworkable. And the other problem is that it's all fixed. If you want to add a disk later, the volume management you're using might let you do that, but you still have to resize the file system and deal with a bunch of details. And it takes, every time you change the configuration, it's got to rebuild the whole array. And that can take ages, especially as disks get bigger. And you're still restricted. I mean, you can't pile 40 disks into a single node and use like RAID 10 or RAID 10 plus 1 or whatever. It just doesn't scale well. Where with this, you could conceivably stack 1,000 servers together, each with its own disk, and you get the combined storage of all of them. And this thing does work in huge supercomputer applications where there are thousands of disks. And apparently it works really well. And it's been used in production with supercomputers and labs to handle all sorts of data loads. So I'm optimistic that this will work for a home lab use where it's just doing file sharing, for a handful of users. Just me and my wife in our case. So anyway, that's how it's going to go. I'm going to give that a shot, and I will document it as we proceed. Wow, this was a long one today, 30 minutes. Ugh. So if you're still with me after 30 minutes, props to you. But yeah, if you've had any experience with Ceph, put your thoughts in the comments. Let me know what you think. And it's going to be an informative experiment at the very least. So I'll post more details as I get this started. It'll be a few months before I really get rolling, but wanted to lay the groundwork today. So until next time, thanks for listening, and I will catch you later.